Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x to the power of 4 is equal to 64. Now for our solution here, so I start with x to the power of x to the power of 4 is equal to 64. Now I'm going to take the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, a here, this is equal to x, m is equal to x to the power of 4, and n is equal to 4. So if I want to convert x to the power of x to the power of 4 to the power of 4 into the form a to the power of m times n, this would be a, so x to the power of m times n. So x to the power of 4 times 4. And this is equal to 64 to the power of 4. Now x to the power of 4 times 4 is simply just 4x to the power of 4. So I have x to the power of 4x to the power of 4 is equal to 64 to the power of 4. Now 64 here, this is the same thing as 8 to the power of 2, or 8 squared. So now I'm going to substitute in 8 squared for 64. So now I have x to the power of 4x to the power of 4 is equal to 8 squared to the power of 64. Sorry, not 64, 8 squared to the power of 4. Now remember how if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So a to the power of 2 to the power of 4, that is going to equal 8 to the power of 2 times 4. And 2 times 4 is 8, so I have x to the power of 4x to the power of 4 is equal to 8 to the power of 8. Now, x to the power of 4x to the power of 4, I can rewrite as x to the power of 4 to the power of x to the power of 4. And this is equal to 8 to the power of 8. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b as long as b is greater than or equal to 1. And in this case, b is 8, which is greater than or equal to 1, meaning x to the power of 4 is equal to 8. So now to solve this, I'm going to take the root of 4 on both sides. So then these two cancel out, and I'll be left with x is equal to the 4th root of 8. Now, to check our solution, our original equation was x to the power of x to the power of 4 is equal to 64, and x is equal to the 4th root of 8. So now if I plug in the 4th root of 8 in this, I get the 4th root of 8 to the power of the 4th root of 8 to the power of 4 is equal to 64. Now the 4th root of 8 to the power of 4, these two will simply cancel out. So I will have the 4th root of 8 to the power of 8 is equal to 64. Now the 4th root of 8, that is the same thing as 8 to the power of 1 over 4. So I have 8 to the power of 1 over 4 to the power of 8 is equal to 64. Now this is the same thing as 8 to the power of 1 over 4 times 8, which is the same thing as 8 to the power of 2. So I have 8 to the power of 2 is equal to 64, and 8 to the power of 2 is 64. So I have 64 is equal to 64, and this is right, so our solution is right. All right, so I have x to the power of x to the power of 5 is equal to 100. Now for our solution, so we obviously start with x to the power of x to the power of 5 is equal to 100. And now what I'm going to do is I'm going to take the power of 5 on both sides. So now I have x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So as you can see, we have x to the power of x to the power of 5 to the power of 5. And in this case, a is equal to x, m is equal to x to the power of 5, and n is equal to 5. So I want to write this in the form a to the power of m times n. So we have a, x to the power of m times n. So x to the power of 5 times 5. And this is still equal to 100 to the power of 5. Now, 5 times x to the power of 5 is 5x to the power of 5. So I have x to the power of 5x to the power of 5 is equal to 100 to the power of 5. Now, 100 here, this is the same thing as 10 squared. So now if I substitute this value in for 100, I get x to the power of 5x to the power of 5 is equal to 10 squared to the power of 5. Now again, remember how if we had something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 5 here. We have x to the power of 5x to the power of 5 is equal to 10 to the power of 2 to the power of 5. That's going to equal 10 to the power of 2 times 5. And 2 times 5 is 10. So I have x to the power of 5x to the power of 5 is equal to 10 to the power of 10. Now, I can rewrite x to the power of 5x to the power of 5 as x to the power of 5 to the power of x to the power of 5. Now this is equal to 10 to the power of 10. And I did this because remember how if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b as long as b is greater than or equal to 1. And in this case, b is 10, which is greater than or equal to 1. So now I have x to the power of 5 is equal to 10. Now, to get rid of this power of 5, I'm going to take the root of 5 on both sides. So now these two cancel out, and I'll be left with x is equal to the 5th root of 10. So this is our answer. Hey guys, welcome back to Clear Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 2 to the power of 10 minus 2 to the power of 9. Now what I'm first going to do is I'm going to rewrite this 10 as 9 plus 1. So we have 2 to the power of 10 minus 2 to the power of 9. And this is equal to 2 to the power of 9 plus 1 minus 2 to the power of 9. Now, an important property of exponents is that if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So the base simply distributes with the exponents. So I'm going to use this property for 2 to the power of 9 plus 1. We can think of 2 as a, 9 as m, and 1 as n. So this would equal to 2 to the power of m, which is 9, times 2 to the power of n, which is 1. And now we are subtracting this with 2 to the power of 9. And now this is equal to, now I'm going to factor out 2 to the power of 9 from this. So if I factor out 2 to the power of 9, I get 2 to the power of 9 times, now 2 to the power of 9 divided by 2 to the power of 9 is 1. And then I have, 2 to the power of 9 times 2 to the power of 1 divided by 2 to the power of 9 is simply just 2 to the power of 1 minus 2 to the power of 9 divided by 2 to the power of 9 is 1. And now this is equal to 2 to the power of 1 minus 1 is simply 1. So I have 2 to the power of 9 times 1, which is equal to, anything times 1 is itself, so 2 to the power of 9. Now, for 2 to the power of 9, this is equal to 2 to the power of 4 times 2 to the power of 5, because, remember, a to the power of m plus n, a to the power of m plus n is equal to a to the power of m times a to the power of n. So now, 2 to the power of 4 is 16. 2 to the power of 5 is 32. So we have 16 times 32. We have 32 times 16. 2 times 6 is 12. We carry the 1. 6 times 3 is 18. 18 plus 1 is 19. Then we add our 0. 1 times 2 is 2. 3 times 1 is 3. 2 plus 0 is 2. 9 plus 2 is 11. We carry the 1. 3 plus 1 is 5. So our final answer is 512.